Hi friends, this is Reshma. Welcomes you to the next session in database management system. Okay, before starting the session, just I would like to highlight in my previous sessions we have discussed about ER modeling and mapping of ER to relational schema, and we know which are the different properties of relational schema. So now in this session we'll discuss about different operations which you can perform on relational schema. So this can be done with the help of relational algebra. So here relational algebra is a procedural language. This is a procedural language, and here these operations are used to retrieve the content of the data of a relational database. So I can say these operations, they will enable the users to specify some basic retrieval request so they can access the data. So with the help of different relational algebra expressions. And here, so we can write a sequence of relational algebra operations, and it will form an expression called relational algebra expression. And here the order we need to specify in which these operations has to be performed. And so one more interesting concept of relational algebra is it will take the input as a relation, and after retrieving the data, result of the query is also a new relation. So now these relational algebra operations are grouped mainly into three groups. One is set operations, then relational database specific operations, and then set functions. So now we'll see which operations will come under set operations and set functions, and then relational database operations. So as we know, in set operations we'll study union, intersection, set difference, and cross product or Cartesian product. Specific operations for relational database are selection, projection, join, and set division. Then set functions, these are same as any other mathematical functions to form sum, average, count, max, min, etc. So now we'll start with basic operations for relational algebra, which are specific to relational data model. So here we have select, project, rename, union, set difference, and Cartesian product. So we'll see what are the symbols we should use. For select, we'll use sigma. For project, phi. For rename, row operator. For union, the union symbol, set difference minus symbol, Cartesian product, into mark. So these are the notations we have to use for these operations in relational algebra. So here I have represented in different ways so that you can remember the different operations. So now again, see these operations again, they sometimes it may categorize as basic operations or extended or derived operators. In basic operations, again we have unary and binary operators. Unary operators are project, select, and rename. So these are called unary because they will be applied on a single relation. On single relation, we'll be applying project, select, and rename operator. In binary operators, it will be applied on more than one relation, that is on two relations. So union of two relation, finding cross product of two relation, finding the difference, set difference between two relations. Using these project and unary and binary different operators, so we can perform extended operations using these derived operators, that is join, allow, join operation, division operation, and then we can perform intersection operation. So now we'll see here what are the importance of making use of this relational algebra. So now this will provide a formal foundation for relational model, and this is used as a basis for implementing and optimizing the queries. And then we can make use of these relational algebra concepts into SQL, that is during a standard query language we will be taking the concept of relational algebra. So now this next is relational calculus. So this is a formal query language, but it is a high level declarative language. As it is high level declarative language, so order is not specified in which operations we need to perform. So here relational calculus indicates what results we have to obtain, but relational algebra will tell how to obtain those relations. So now relational calculus has two variations. One is tuple relational calculus and domain relational calculus. In tuple relational calculus, so it is a non-procedural query language. It will just provide description of the query, but it will not describe the different methods to solve. It will just explain what to do, but not how to do. And in tuple calculus, a query is expressed as T perpendicular line P of T. Next, in domain relational calculus, which is also a non-procedural query language, again it will provide only description, but it does not provide methods, and it will be expressed like this. So where x1 to xn represent domain variables, P of x1 to xn indicates the conditions or the formulas, which are similar to predicate calculus. So now we'll just see some of the difference between relational algebra and relational calculus. So relational algebra is procedural language, but relational calculus is declarative language. Relational algebra, it will helps us to know how to obtain the result, but calculus, it will just tell what we have to obtain but not how. So hence in relational algebra order is specified. In relational calculus order is not specified. In relational algebra it is independent of domain, but relational calculus is completely depending on the domain. And relational algebra expressions, they are rarely nearer to programming language, so that directly it can be used in new structured query languages for the implementation. But relational calculus, they are not near to programming language. So these are some of the difference between relational algebra and relational calculus, and some of the operations of relational algebra. So this is about the basics of relational algebra and their operations. And in next session, we'll discuss about the different relational algebra operations. We'll start with unary operations select. So to get the videos about how those operations will be used, just subscribe and get notifications about the next videos. Thank you.